Hello everyone, this is Dr. Mohana Roopa, working as a professor in the Department of Computer Science and Engineering at Institute of Aeronautical Engineering, Hyderabad. Welcome to all for lecture series of software engineering course. Today's topic, COCOMO model. In this COCOMO model, we have to learn on software cost estimation, COCOMO model introduction, as well as different types of COCOMO models. The outcome of this particular topic, COCOMO model, is illustrate the process models, approaches and techniques for managing a software development process. First one, software cost estimation. Software cost estimation is process estimate the approximate cost of software project before software development process starts. That is, the software cost estimation describe the approximate requirements in terms of efforts, in terms of how many number of resources are required, what are the cost for the resources, all the thing to complete the particular software project. This is there in software cost estimation process. Actually, this cost estimation process is the activity of software project management. So one of the major activity of the software project manager is cost estimation. Software cost estimation. Before starting the project, estimate that project that gives the good software development. So what is there in the software estimation process? Always process, before the process some inputs are there. So after the process some outputs will come. The software cost estimation process uses the inputs as size tables, lines of code, number of use cases, function points. These are the estimation process inputs. So using these parameters as inputs, then we'll calculate, after completion of estimation process, we'll get that efforts and development time, number of personnel and errors. These are the outcomes we expect from the estimation process. So input means almost all cases here lines of code. Lines of code. How many lines of code is required to complete the particular project? At the same time, the project size estimation in terms of functional points also. How many number of functional points are required to complete that particular project? So these are the inputs. Then the estimation process is complete. So then here efforts will get. Efforts in the sense, efforts in terms of person's work. Person's work in terms of months or in terms of hours, in terms of weeks. What are that? How many number of persons are, person's efforts, their workload required to complete that particular product. So that is there in the effort. So as well as next one is development time. How many number of months will take to complete that particular project? That means in terms of days or in terms of weeks or in terms of months, generally will define in terms of months. So that is development time. As well as we'll get that number of persons. How many number of people are required? Human resources are required to complete the particular project successfully. So that is also we'll get from the estimation process. Then any time errors are occur, those what kind of errors will come. So how we can estimate that error analysis, like that things are also get from the estimation process. So generally in the software estimation, cost estimation process may contain different models. So under that, the common method generally used estimation method is COCOMO model. So COCOMO model, what is that COCOMO model? Dr. Barry Boham proposed COCOMO, that means constructive cost estimation model. So in the constructive word CO as well as cost here again CO, then estimation model here MO. So these three, what are that words? So that becomes as COCOMO, constructive cost estimation model. In 1981, the Dr. Barry Boham proposed constructive cost estimation model for development of softwares. So in 1981, he proposed. So COCOMO model is one of the most generally used software estimation model. So through this cost estimation model, it predicts the efforts and schedules of a software. Efforts and schedules of software product based on the size of software. See, the previous what we discussed here. So that is the process, estimation process contains estimation process. Take as input size of software. Size of software. And we'll get that efforts and schedule, development time. So these are the outcomes and as well as this is the input of estimation process. This estimation COCOMO model take the size of the software as the input and efforts, then as well schedule, as well number of persons. Number of persons are also known by using the COCOMO model in the estimation process. What are the necessary steps are required to estimate the cost by using that COCOMO model? So here, first one is initial estimation of development effort. First estimation of the effort from evaluation of thousands of delivered lines of code. So, or simply KLOCs, kilo lines of code. So, input as kilo lines of code as well as the output is effort. To estimate the effort by using that KLOCs, kilo lines of code. So, next one is determine a set of 15 multiplying factors, different factors from various attributes of the project. Take these attributes and calculate the effort estimation in the initial estimates with multiplying that factors, different factors. Those factors are applied from step 1 to step 2. So these are the different steps, necessary steps are required to complete the COCOMO model to compute efforts. So next one is generally here the basic method is nominal estimation. That nominal estimation of the cost is also using kilo lines of the code. That is the measure of the code. Here by showing the simple equation, the efforts to determine the initial efforts, EI, initial efforts is equal to A into KDLOC into B. So here A, B are the constant value, depends on the project type. So that's why here the project type is important in the COCOMO models. So the COCOMO models projects can be apply COCOMO models for calculation of the efforts and the time schedule for various kinds of projects. What are the categories of those projects? So here the categories of the projects are organic kind of projects. So next one is semi-detached kind of projects. So then next one is embedded kind of projects. What is organic? So organic project is very simple, very small kind of projects are categorized under organic type. under organic type. That means very small projects as well as small project team with a small prior experience, as well as the problem is well understood and has been solved in the past. This kind of what are that previously these projects may completed. So those are considered for this actual project under this organic. So as well as requirements of the projects are not rigid, there is no rigid requirements, already predefined requirements. Mode of example is suppose some example like payroll systems, like very small student database systems, like that. So these all are under that organic projects. So categories of the projects are organic. COCOMO projects are applied for organic projects. COCOMO models are applied for semi-detached projects. COCOMO models are also applied for embedded kind of projects. So semi-detached projects are mixture of experienced and inexperienced faculty, staff are required to complete that particular project. So semi-detached here, some organic properties, some what is that embedded projects. So but embedded kind of projects is very complex or coupled of complexity, very complex problems are there. That means hardware requirements as well as the software requirements, both combinations, such type of projects are also there in the embedded software, embedded projects. So then based on these, what are that? The size estimation is in terms of kilo lines of code, project estimation in by using that KLOC, that is project, size of project, then project duration in months, efforts in persons, by using some equations, So here different kinds of COCOMO models are there. What are the different types or different kinds of COCOMO models? Here basic COCOMO model, second one is intermediate COCOMO model, third one is detailed COCOMO model. So basic models, intermediate models, as well as detailed model. COCOMO model kinds. So first basic COCOMO model. So which can contains what is there? What is the purpose of basic COCOMO model? Where we have to apply this basic COCOMO model? In the sense, here it is, by using this basic COCOMO model, we can estimate the nominal parameters, nominal values, nominal estimation, basic estimation is there in the basic COCOMO model. We have to apply that basic COCOMO model for any kind of projects, either it may be the the embedded models, or it may be the other models like other models. So then what is the estimation of the scope? What is the estimation of efforts? So first effort A is equal to A1 into KLOC into A2 in terms of PM. PM stands for person months. Person months. So that is the unit for efforts calculation. Effort E is equal to, simply E is equal to, next development time. Development time TDV. Development time TDV. D is equal to TDV, that is equal to B1 into efforts. Here efforts E into B2, that is in terms of months. In terms of month, that is there in the basic COCOMO model. So not only this, P is equal to persons. How many number of persons are required to complete that particular project successfully? That is P is equal to always E divided by D. That is in number of persons required. Number of persons are required to complete that project. So where KLOC is always size of estimated size of software project. So indicated in terms of kilo lines of code. Kilo lines of code always KLOC. Where A1, A2, B1, B2 are the constants of each group of software projects. So TDV is almost development time, time to develop. Efforts is, what is that? Efforts are person in months. Efforts are person. Total efforts required to develop the software product expressed in terms of person month. P is equal to effort divided by time, that is total number of persons required to accomplish the project. So estimation of the development effort. How we can estimate that development of effort? First of all, E, calculation, organic type. Here three kinds of what are the projects are there? Categories of the projects are organic categories, semi-detached category, as well as embedded categories. So the COCOMO model, basic COCOMO model applied for organic type of projects. How to calculate the effort? Effort E is equal to 2.4. Here 2.4 is constant value A1. Actual formula A1 into KLOC into A2 or B, here B, PM. That is PM is persons months. So A1 KLOC B or A KLOC B. So next semi-detached also the same. A, B values. And efforts is equal to A, B values. See here different values are there for are used for semi-detached and embedded. So as A values and B values. How we can know the A values and B values? In the sense, the tabular values are required to compute that effort by using the COCOMO model. So through that COCOMO model, here what are that? The software project estimation calculation. So some table values are required, constant values. Suppose organic kind of projects, we want to calculate that cost, software cost. So then what is that cost estimation by using the COCOMO model? So here A value is 2.4, constant value, predefined value. B value is 1.05. See here, this is organic A into KLOC into B. So that's why A value is 2.5, B value is 1.05. Those are already predefined in the table by the Bohemans. So then semi-detached. This is semi-detached. The value of A is 3 and B value is 1.12. That's why here 3.0 than 1.1. So next one is embedded kind of projects cost estimation, that is 3.6 into KLOC into B. So from the table, that is 3.6 and A value is 3.6, B value is equal to 1.2. So this is the for table values we have to use and find the efforts of effort calculation by using the COCOMO model for the different categories of the projects, right? So next, what is that? Estimation of development time. So estimation of the development time calculation here CD. So D is equal to capital D or TDV is equal to C into effort E into D. So this is the value. C, D values from the table we have to take it and as well as calculate that development time, estimation of development time. So C value for organic kind of projects, C value is 2.5 and what are that here? D value is 0.38. So C value 2.5, D value 0.38. Similar way, semi-detached kind of projects cost estimation, that is equal to 2.5 into 2.5 efforts E, then automatically whatever the value from the table, that is 0.35. 2.5, 0.35. So for embedded kind of projects cost estimation, it is 2.5. So C value is 2.5, D value is 0.35. 3, 2. So those are from the table. So like this way, we have to calculate that time, what is that development time, estimation of development time. So the same thing is applied with the, for example, so suppose a project was estimated to be 400 KLOC. That is the problem. The size of the project is 4000 KLOC. Calculate the effort and development time for each of the three model, that is organic, semi-detached and embedded. Same principle we have to apply. So what is that effort? A is equal to A1 into KLOC into PM. So size estimate, TDV is equal to in terms of months, PM is equal to in terms of what is the effort is equal to in terms of PM, person months. So estimation size is equal to 4000 KLOC. Organic model. So A value we know that, A1 value we know that, A2 value also we know that from the table. So then we'll get that like this. So here D is equal to, time D is equal to, what is that here, effort, lines of code is equal to 4000, what are that KLOC, and these two values from the table we have taken. So then the values are, the value of effort is equal to 1295.31 we'll get. So then D is equal to development time is equal to 2.5 into efforts, this effort value, this value, and 0.38 from the table. Then we'll get that 38.07% per month. Month or what are that here, only the months. So P is equal to number of persons required. So E by D, capital E by capital D. So then we'll get that 34 number of persons are required to complete that particular project successfully. So same thing is applied by using that semi-detached mode values. So then the persons required for semi-detached, that is 64. For embedded mode, so it requires 126 number of persons to complete that particular model. This is basic COCOMO model. Next, go for intermediate COCOMO model. Next kind of COCOMO model is intermediate COCOMO model. Generally, the basic COCOMO models are the nominal estimation, gives nominal estimations, basic estimations. So to get that more accurate values, calculation of the cost using that COCOMO model, intermediate level, that means intermediate COCOMO model. So that's why in the basic COCOMO model uses only one input as a KLOC. So one parameter, take only one parameter and estimate. That is very basic level. Here what are the drivers, cost drivers, some parameters are also taken to calculate that cost estimation. So 15 cost drivers, those are also predefined models from different various kinds of what are the attributes of the software engineering. So what are the different kinds of what are the attributes as well as the cost drivers for their attributes, classification of cost drivers and their attributes. So what kind of attributes may taken into the consideration and calculate the software cost estimation by using that intermediate model. So what are that here? Product attributes, hardware attributes, then what are that? Personal attributes, project attributes. These are the 15, what are that? 4 categories of what are that attributes or cost drivers for the attributes. 4 kinds. Under the 4 kinds, 15 attributes are taken into consideration in the calculation of the cost estimation. So, for example, product attributes are required software reliability extent. Suppose RLX. So, size of application database, complexity of the product. Those are product related attributes. So, next hardware attributes are runtime performance constraints, memory constraints, volatility of that virtual machine environment. So other kind of personal attributes are example, analyst capabilities, software engineering capabilities, application experience, so virtual machine experience, and programming language experience. These attributes are also taken into the consideration to calculate that estimation. Similar way, some kinds of project attributes are use of software tools as well as some applications of software engineering methods and required development of schedules, like all the parameters are as well as the attributes are taken into consideration depends on the problem application. That means kind of the problem. What are the different attributes are need to compute that particular cost estimation of the problem. Those are take. Actually, these project attributes has also some different values. Some different values, those are considered as EAFs. EAF is effort adjustment factor, which is calculated by multiplying the parameters values of different cost driver parameters. So ideal value always it is 1. EAF ideal value, that is normal cases. So the EAF values are also used for very low cases or high cases, whatever that medium, as well as some other what are that complexities are also taken and find the EAF values. Those EAF values are also there in the different tables. So predefined tables. So generally for normal cases, this value is always 1. EAF value is always 1. So through this nominal, what is that? Through this intermediate process, intermediate COCOMO model applications. So E is equal to effort calculation. Through this, always through the COCOMO models, either it may be the basic or it may be the intermediate or it may be other detailed COCOMO model, whatever the model. So calculation of effort is important. Calculation of development time is also important, as well as number of persons are required to complete that particular product. So those are the outcomes, and the inputs are for the basic COCOMO model. It is only the lines of code, and what are that through that intermediate code, some other 15 key cost drivers are required. Those are defined through that different what are that tables, right? So generally the values A1, B1, C1, D1 values are also differ for using what is that apply the COCOMO models generally. So the values are E is equal to A1 KLOC, B1 into EAF values by using this table, and calculate the efforts as well as the development time, as well as what is the number of persons required. So that is there in the intermediate COCOMO models. Next model is detailed COCOMO model. Third kind of model COCOMO model is detailed COCOMO model. Generally, this model gives that better and better quality of that cost estimation, accuracy. The accuracy of the cost estimation is also get through the detailed COCOMO model. This detailed COCOMO model generally total project can be divided into modules. For each and every module, we have to apply this detailed COCOMO model, then calculate the efforts as well as efforts, then what are the development time, and P per number of persons, right? So here the different stages of the same detailed COCOMO model is applied for different stages of software development process model. So here from the different phases means from requirement gathering to finally up to maintenance, like requirement gathering, analysis, design, then testing, then finally what are that implementation, testing, then deployment, and last one is maintenance. Up to maintenance, different phases or different modules, whatever that, apply the COCOMO model and calculate the cost estimation. So here also uses different multipliers for each phase of the project. It is very complex mode. It includes more factors that influence the software projects and give more accurate estimations. So this is important. That's why for very complex problems or very large applications, we have to use the detailed COCOMO model and calculate the cost estimation. So the phases, 6 phases are there. The 6 phases of detailed COCOMO models are in the planning and requirement. So then system design, system analysis, then detailed design, then module code and test. That means implementation and testing. Finally, integration testing, then cost constructive model applied. So these are the different phases are there in the detailed COCOMO model. So a major purpose of this one is reduce the marginal errors. So this approach then reduce the marginal errors, and finally a good estimation or better estimation is also possible to the detailed uh, COCOMO models. So by using these references, we have to finish this particular topic. Right. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.